But we're going to talk today. This says section 4.4, I know, but this is just like the rest of the conjugate pairs that we started to talk about last week. Was it last week? Earlier this week, something like that. But the conjugate pair theorem is, remember, if you had a 0, like say they said the zeros were, I don't know, 3, 7, and the square root of 2. What else did I have to include in this list? Which opposite? You're right. They're one of the opposites we have to include. Which one is it? The square root. I also have to say, ooh, I have to have the negative square root. Because if you have square roots, you have to have the positive and the negative so they cancel out. So we're going to do the exact same thing, but we have to have the conjugates of imaginary. So remember, an imaginary number has a real part, like a 4, and then minus the imaginary part, 3i. But we can't have i's in our original polynomial, so you have to account for the opposite. What's the conjugate? What's the opposite of 4 minus 3i? 4 plus 3i. As long as you're written in standard form, to where you have the real part first, the imaginary part second, you keep the terms the same, but what you do is change the sign in the middle. And the reason why is this. When I multiply these together, what happens here? 4 times 4 is 16, right? 4 times 3i, 12i, good. Negative 3i and 4 is negative 12i. And what's negative 3i and a negative 3i? Minus 9i what? Squared. As soon as I see that squared, I cross it off, and I change that sign in front, because I squared is the same as negative 1. So cross off the sign, cross off the I, change the sign in the front. So what happens here in the middle, guys, with a positive 12i and a negative 12i? They cancel. So you're left with just 16 plus 9, which is 25. So the reason you have to account for the conjugate pair is because you have to have the i's cancel out. Does that make sense? All right. Now, this is not terribly hard. Pain. It is a pain in the butt. I'm telling you that. There is a little bit of a shortcut that I'm going to show you. If you like the shortcut, that's great. You can always use it. If not, you can do it the long way. So I'm going to look here. Write the polynomial function, blah, 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 blah. The leading coefficient of 1. So that means your x squared is 1. And your zeros are 2 and 3 plus I. So I'm going to write down x equals 2. X equals 3 plus I, and what's the other thing I have to account for? X equals 3 minus I. Whenever you have an imaginary, you have to account for the positive and the negative, the conjugate, so the i's will cancel out. So the first step here, guys, is just to write everything in parentheses. How do we do that? We take this and move it to the other side. So my positive 2 becomes negative 2, so x minus 2. All right, this positive 3 plus I becomes what? X minus 3 plus I. Look how I wrote it. And then this is positive, correct? When I bring it over, this becomes x minus 3 minus I. Now, some of you are going to notice something, and you'll see it in a second, and that's fine. So I have my x minus 2. When I distribute this negative, what does this become? X minus 3 minus I. Agreed? Then when I distribute this negative here, this becomes x minus 3 plus I. You guys see that? Some of you are like, well, when I bring it over, can't I just change the sign? Yes, you can do that if you want to. If it's a positive, do you see how 3i and 3 plus I and 3 minus I are both positive? When you bring it over, this sign stays negative, and then the second sign changes. Do you see that? That'll happen every time. You don't have to do that, this step right here of distributing or whatever. Just make sure the first sign is the same, second sign is different. Now, I'm going to work this problem out 2 ways. I'm going to go the long way, and then I'm going to go the short way. So, long way first. I'm going to stick this x minus 2 out in here. We'll deal with that in a minute. And all we're going to do here is FOIL. We're going to multiply everything in the first times everything in the second. It just takes a second. So, x times x is x squared. X times negative 3, negative 3x. x times I, just stick them together, plus xi. Everybody with me? Now I'm going to take the second term, negative 3. So negative 3 times x is minus 3x. Negative 3 and negative 3 is plus 9. And then negative 3 times positive I is minus 3i. Everybody with? Now what's the last thing I need to do? The negative I. So negative I times x is minus ix, or xi, however you want to write it. Negative I times negative 3 is plus 3i. And negative I and a positive I is minus I what? Perfect. When I see that I squared, what do? Cross it off and change that sign. So it's really just a plus 1. Now this is a big mess. We have to clean up our mess. So I still have my x minus 2 hanging out. So let's clean this up. Anything have an x squared with it? Nope, so just write x squared. All right, a negative 3x, a negative 3x. Anything else have just an x? What's negative 3x and negative 3x? No, you're right. Negative 6x, good. All right, I have a positive xi and a negative xi. What do? They cancel. I have a negative 3i and a positive 3i. What do? Cancel. So then I have a positive 9 and a positive 1. What does that become? Plus 10. Now, guys, what happened? Where did all of my i's go? They canceled out. And so that's why you have to account for the complex conjugate, because when you multiply them all together, your i's should cancel out. You should never have an I in your polynomial. Now, what do? We just multiply again. Just takes a second. X times x squared gives me x cubed. Good. X times negative 6 is negative 6x. Perfect. X times 10 is 10x. Good. Negative 2 at x squared is minus 2x squared. Negative 2 and negative 6 gives me positive 12x. And negative 2 and 10 is minus 20. And now we just combine like terms. At the beginning, f of x, g of x, h of x, doesn't matter. Whatever you want to do. Just write it as a function. Now we write our polynomial in standard form. So my highest exponent is x cubed. Do I have anything else with any cubes? No? Okay, so now negative 6x squared, negative 2x squared gives me negative how much? 8x squared. Okay, so I have a 10x plus 12x gives me, perfect, plus 22. And then what happens with my little minus 20? Just sticks out right here. So there is your polynomial. What you guys are used to is me give you this, and then you work it all out and tell me that the 3x's are here, here, and here. So all we're doing is going backwards. All right, is this like, oh my gosh, this is so hard? No, is this a huge pain? Absolutely. You make one problem, one issue with your sign and everything's wrong? Yeah, that's annoying. So let me show you the shortcut, okay? I'm going to do the shortcut from now on. If you like the long way, that's fine. It'll work out the same every time, but I'm going to do the shortcut. I'm going to show you. So we started off with x equals 2, x equals 3 plus I, and x equals 3 minus I, correct? You guys agree? All right, so I'm going to do the same thing. I'm going to move them over. X minus 2. This is going to be x minus 3 minus I. X minus 3 plus I, right? Okay, here's the shortcut. X minus 2, still hanging out here. What do you notice about what I have in white and then what I have underlined in pink? Look at the two. Compare the two things I have underlined in white. Are they the same? Yes. Whoops. Look what I have underlined in pink. Are they the same? Yes. What do you notice about the sign in the middle between them? It's what? The same or different? Different. If I said to you guys, how would you factor this? What would you tell me? x squared minus 9, what would that break down into? X plus 3 and x minus 3, okay? What about if I said x squared, 4x squared minus 1? 2x minus 1, 2x plus 1, right? What is that called? The difference of squares. Every single time you guys do this, it just doesn't happen sometimes. Every single time we do one of these problems with a conjugate pair, you can take a shortcut, and you can take what we have here in white. The first, you can say, I have x minus 3 quantity squared. Then you can take what we have pink. We have I squared, right? And then what sign would go in the middle? A minus. This is the difference of squares. And you can treat this like this and then FOIL it out. Again, we're going to do this a couple times. We still have our x minus 2 out in front. So think about what this looks like. X minus 3 quantity squared. What does that look like? X minus 3 times what? X minus 3, right? Minus, what is I squared? Negative 1, okay? So let's go one more step. Say x minus 2. When I FOIL this, what's x times x? X squared, good. So then I have x times negative 3 is minus 3x. Negative 3 and x is minus 3x. What's negative 3 and negative 3? Plus 9. And then what happens when you have minus a negative? It's a plus, okay? So I have x minus 2, and then let's just clean this up. X squared minus 6x plus 10. Is that the same thing we had right there? Yes or no? Yes. That pattern will work every time. There's some of you in here that are like, what? That doesn't make sense. That's okay. We can keep trying. Or you can just stick with the regular up here with the I's and the XI's and all that stuff. I just find that it's much easier to make a mistake when you do it that way. This pattern will hold true every single time. We're going to do a couple more examples, and we're going to do it that way for you guys to try, and it saves time. You don't have to mess with the X and the I's and all that stuff. It just kind of, to me, it makes a little more sense. Can I go on? Okay. Again, you guys aren't going to go through the checking of that. All right, let's do this one. Hold on. Okay. How many zeros did they give me here? 2. But what do I know I need to account for? I have to account for the I. So I really have x equals negative 1, x equals 4i, and x equals negative 4i. Good. All right, so let's go backwards. We're going to go into parentheses. My first parenthesis says x what? Plus 1. Perfect. My second parenthesis says x minus 4i. My third parenthesis says x plus 4i. All right, deal with the imaginaries first. Excuse me. So I have x plus 1. Now I'm going to use the trick. Do you guys notice I have x as my first term? I have 4i as my second term, and then what are the signs in the middle? The same or different? Different. So this is the difference of perfect squares. So I'm going to take the first term and square it. Then I'm going to take the last term and square it, and then put a minus sign in the middle. Every single time that will work. So I have x plus 1 times, what's x squared? X squared. And then this 2, remember, goes to the 4, God bless you, and to the I, correct? So so I have minus, what is 4 squared? 16, and then what is I squared? Okay, so watch what happens with your I squared. We cross it off, and this becomes a plus. So now, x times x squared is x to the third. X times 16 plus 16x. 1 times x squared is plus x squared. And 1 times 16 is plus 16. Can I leave my answer like that?
No.
Why not? Not in standard form. You need f of x, g of x, h of x, something at the front, and then I have x cubed plus x squared plus 16x plus 16. Now, if you guys didn't do the trick, if right here you FOILed this out, you would have gotten the same thing. X times x is x squared. X times 4i is plus 4xi. Negative 4i and x is minus 4xi. And then negative 4i and positive 4i is minus 16i squared. So your I squared would cross out. You get a plus sign here, and then these would cancel, which gives us the same thing. Just a little bit of a shortcut. I'm going to do the last example right now, and then I'll come back to number 6. I'll do it on the video. But I just want you guys to see a big one like this, and then you can ask me questions on homework. How many real zeros do I have here? I have 3. What are they? Oh, actually, the way it's written, I'm sorry, I read it the same way you did. I read it like this. Root 2, 1, and that, but that's not what it says, now that I reread it. This says x equals the square root of 2, and this says x equals 1 minus 3i. You see that? So actually, I have 2 real zeros here, which is probably what you were answering. I looked at it a different way. But how many total zeros do I have? 3 or 4? I have 4. Because I have x equals the square root of 2, I also have to have x equals what? Negative square root of 2. The only time you don't have to account for a conjugate is when it's just a nice, pretty whole number. What about if I have x equals 1 minus 3i? What else do I have? X equals 1 plus 3i. All right, so we have 4 zeros, actually. No big deal. We can handle this. Let's go into parentheses. So this is x minus the square root of 2. This is x plus the square root of 2, correct? You guys with me? All right, this is x minus 1 plus 3i. I already distributed the negative. This is x minus 1 minus 3i. Just make sure the first sign is the same, second sign changes. Now, don't try to combine the irrationals with the imaginaries. Deal with things separately. You want to multiply this first? Go ahead. What's x times x? X squared. What's x times root 2? Plus x root 2. What's negative 2 times x? Negative root 2 times x is minus x root 2. And then what's a negative square root of 2 and a positive square root of 2? It's minus the square root of 4. So what happens with these in the middle? They cancel. So you have x squared minus, what's the square root of 4? 2. Perfect. So now let's deal with this other stuff. I have the difference of squares. What is my first term? X minus 1 squared. Okay, what is my second term? 3i. And I square it. And then what goes in the middle? A minus sign. So I have x minus 1 times x minus 1 minus, don't forget, this 2 goes to the 3 and to the I. So that becomes what? Minus 9i squared. Agreed? As soon as you see that I squared, guys, what do? Cross it off and change that sign in front. No more i's. And now we can FOIL this. What's x times x? X squared. X times negative 1 is minus x. Negative 1 and x is minus x. Negative 1 and negative 1 is plus 1. And then I have plus 9. So now I have x squared minus 2x plus 10. And this, ladies and gents, is now what we multiply together. Take your time. X squared times x squared is x to the 4th. X squared and negative 2x is minus 2x what? Cubed. X squared and 10 is plus 10x squared. So negative 2 and x squared is minus 2x squared. Negative 2 and a negative 2x is plus 4x. And negative 2 and positive 10 is minus 20. And just combine like terms. Does anything else other than x to the fourth have a fourth exponent? So I have x to the fourth. What about x to the third? Just the minus 2x cubed? What about right here? What does that become? Plus 8x squared plus 4x minus 20. Long process. I get it. But the biggest thing you have to keep in your mind, guys, is if you have a radical or if you have an imaginary, you have to account for the conjugate, the positive and the negative. And the reason why is you want everything to cancel out. That makes sense? All right, I will stop now. Okay, guys, in example 6, we're dealing with radicals and imaginaries at the same time, but we're going to deal with the exact same way. So I have x equals 3, and I have x equals 1 plus I square root of 5. Since I have a radical and or imaginary, I have to account for the conjugate, so I also have x equals 1 minus I square root of 5. So when we go backwards and we put everything into our parentheses, I have x minus 3. This is going to become x minus 1 minus I square root of 5. This is going to be x minus 1 plus I square root of 5. So we're going to leave our x minus 3 just hanging out here in front. We'll deal with that in a second. And then we're going to use our special patterns, that little shortcut we talked about, to go ahead and write the difference of squares. So my first term is going to be x minus 1 quantity squared. My second term is going to be I square root of 5 quantity squared. And then we have our minus sign in the middle. So my x minus 3, again, we're not doing anything with it. So I'm going to go ahead and FOIL. I have x minus 1 times x minus 1. Then I have minus. Remember, this squared goes to the I and to the radical 5. So this will be square root of 5 times the square root of 5 is just 5. And then I times I is I squared. So guys, as soon as you see that I squared, what should we do? We need to cross it off and change the sign in the front. So now I just have positive 5. So I have my x minus 3. And then we're going to go ahead and FOIL combine like terms. So we have x times x is x squared. X times 1 is negative x. Negative 1 and x is negative x. Negative 1 and 1 is positive 1. And then I have plus 5. Now we can combine like terms. Still have our x minus 3 out here. So we have x squared. Negative x and negative x is minus 2x. And 1 plus 5 is 6. So now we've gotten rid of the radicals, and we've gotten rid of our square root. With the square roots, and we've gotten rid of our i's. So now we're just going to multiply. X times x squared is x cubed. X times negative 2x is minus 2x squared. X times 6 is plus 6x. So then we will have negative 3 times x is minus 3x squared. Negative 3 and a negative 2 is plus 6x. And negative 3 and 6 is minus 18. So remember, we're writing a polynomial. So we want to start off with f of x, g of x, h of x. Doesn't matter, just write it in function notation. And then we're going to write in standard form, so descending order of our exponents. So I have x cubed. Do I have anything else that has an x squared? Yes, I have a negative 2 and a negative 3. That gives me minus 5x squareds. Then I have a positive 6x and a positive 6x gives me plus 12x. And then my minus 18. There you go.